Hello everyone, I'm Necmettin. Welcome to my C++ linked list program I wrote. Today I'll try to explain all of the code uh, on here, and I'll try to explain this code line by line as much as I can, but as you can see it's really long and maybe confusing for you. If you wish to understand the code, just stop the video and try to read the comments I wrote for the code and try to understand the logic of the code. And this code includes classes, structures, methods, switch cases, pointers, etc. And I wanna start from the main section, integer main. I created an object called instance related to a linked list with the integer data type. Uh, it's automatically executes our constructor in the class, and I declared two variables on here called choice for the switch case and loop status for the while loop. And I created a basic user interface on here, as you can see, and with the help of the switch case, when you type 1 on your keyboard and press enter, you're gonna execute this add method. It it executes the add method, and you are appending elements to your linked list. When you press 2, you're gonna delete a specified element from your linked list. When you press 3, you're gonna search for the specified element in the linked list with the element counter. And when you press 4, you're gonna print all of the nodes from the linked list. And when you press 5, you're gonna instantly close the program. And when you enter invalid selection, like for instance when you type 10 on your keyboard and press enter, this default block will be executed, and this warning message will appear in front of you on your screen. Invalid selection, try again. It puts the user from the beginning of this main section again. And let's get the uh, real deal section, I can say, the classes, pointers, and structures. uh, it's a bit confusing maybe, but I'll try to explain all of it. First of all, I wrote the template statement on here, class Necmettin. This Necmettin allows me to use different data types uh, on the same variable name. For instance, I can use integer and string on the same variable, but in this program it doesn't allow me to use other data type except integer, because I created my object with the integer data type, so it doesn't work on this section. And when you type string or char or maybe boolean, you're gonna get some unforeseen situations, like putting the code in an infinite loop and making it crazy, and so on. And when we get the class side, I created a class called linked list, and on this section I opened my private section. I created a structure called node, and I defined two variables. First one is the item on the Necmettin. uh, like I said previously, it allows me to use different data types, but for this code it only allows me to use integer. Because of this, let me show you. Because of this statement, linked list integer instance. Okay. And when we get the node asterisk next, this next pointer related to node is for the next node's memory address. Okay. The node will store the next node's pointer address, and it's gonna point the next node. And I also declared uh, some variables on here again, like integer length. uh, is for the length of the list, and asterisk head and asterisk tail is for the uh, head and the first nodes and the last nodes memory address. The head will hold the first node's memory address, and tail will hold the last node's memory address. And when we get the public section, I created my constructor on here, and when we create a object, we're gonna execute this constructor side automatically, and head and tail will start from the null, and length will be equal to 0 because there is no node in the linked list right now when we create a new object. When we get this void add method, we're gonna we declared again Necmettin element. Like I said previously, it could be in any data type, but it only works with the integer. And I created a new node of list. Let's call it to new node, and new node of list equal to new node. We created a new structure called new node of list related to the node structure. Okay, uh, we we are inputting our element on here, and we are appending our new node, as you can see, new node, and new node's item will be equal to element. Uh, we are putting the element's value to new node's item, and new node's next pointer will point to null. Okay, because it's the last node, and the last node cannot point to any nodes. And when the length equals to 0, when we are appending our node, head and tail will be equal to memory address of new node, because there's only one node. And when length is not equal to 0, uh, our last node called tails next pointer address will point to new node, because we are adding a new node to our linked list, and our tail will be no longer the tail, and the new node will be the our next tail. Okay, the new tail. And declaring we are defining the new node to tail. Our new tail is new node right now, and we are increasing the length on here by increasing the value 1. Okay, when it's 0, it's gonna be the 1. When it's 1, it's gonna be the 2, and so on. And on this delete method, as you can see, maybe it's a bit confusing for you, because firstly it was supposed to uh, delete the old specified elements from the list. For instance, when I type 1, and there are 3 number ones in the linked list, it was supposed to delete all of the number ones from the linked list, but I encountered with some errors, like uh, it wasn't deleting the first and last node, and I tried so hard, but it wasn't work. So I derivated my program like this: when you delete a specified element, and there are 3 of them, uh, it will only delete one of them, and the specified number uh, will be the 2. Okay, there will be 2 specified numbers, because we deleted one. And we declared Necmettin element again, as you can see, and primary will start from the primary null. Will start from the null, and secondary node pointer will be equal to head. It will start from the head, and this is found section for the informing messages. And we are inputting our element on here, and on this while section, while our secondary is not equal to null, is if our secondary is null. Okay, uh, it means that our secondary reached to uh, last node. Okay, uh, even it passed the last node. If our secondary, if secondary's item is equal to element which I inputted here. Sorry for my dry throat, by the way. Let me drink some water. Yeah, where I left. Okay, this secondary section. Secondary I is if secondary item equals the element, we're gonna make the is found true for this message section. If there is no specified element, it says doesn't exist in the linked list and so on. Uh, we created a temp not variable, pointer variable, which uh, which is equal to uh, secondary's next node. Okay, and we are deleting the secondary, and we are decreasing the our length value because we deleted the one node from our linked list. And when our temp is not equal to null, I mean it doesn't reach the uh, tail node. Okay, our and if primary is equal to null, and like I mentioned here, it's for the starting section, starting from the tail node. We are making this adjustments on the memory address on here. As you can see, it's a bit complicated, but I'll try to explain. Okay, and we are we are appending the temp to primary. We are uh, we are defining primary to head, and secondary will be the temp's next pointer. And our primary will be no longer null. Okay, we started our program here, and if when our program when our primary is not equal to null, and we found a secondary's item, secondary temp, primary next secondary, and break. As you can see, there are so many process on here. I would want to explain, but it's really so long, by the way, and video the video got really long, by the way. Sorry for that. And uh, let me explain the main logic. Okay, when you delete the secondary pointer, secondary node, uh, our primary node, uh, our primary node's pointer section will point the uh, new secondary node, which is the deleted nodes, which comes from the right after the deleted secondary node. Okay, that's the main logic of this delete delete block, and I considered all the cases for that. And as you can see, uh, when we couldn't find item equals to element, the program sorry, when secondary is not equal to null, okay, we are increasing our primary to secondary, and secondary's next pointer will be equal to secondary. Okay, uh, but if it doesn't get this if block, and in this warning message section, when we found a specified element in the linked list, our is found will be the true, but if it's false, it says doesn't exist in the linked list, the warning message. And if the length is equal to 0, I mean if we delete all of the nodes from the this delete section, there will be a new message called no nodes exist in the linked list, please append node. uh, there was a similar one. Where was it? Let me find it. Yeah, if length is equal to 0, it says no node nodes exist in the linked list, please append node. If our nodes are depleted in the linked list, and when we get the search method on here, uh, it's a lot easier than the delete, because delete is really confusing, and you have you really have to think about it when you are supposed to considering all the cases. And like I previously mentioned before, and it was supposed to delete all of the specified elements. And on this search section, we're gonna start from the head, and we created a asterisk temp pointer variable related to node to head. We're gonna start from the head, okay? And I also defined a I equals 0. This is for the counter for the specified element. Like if we type number 1 for searching, and there are 3 number ones in the linked list, then our counter will be equal to 3. And I created uh, 2 booleans on here, loop status and is found. And this is found boolean is for the messages again, and this is for the loop statement. And as you can see, uh, if temp equals to null or length will equal to 0, our loop status will be false, and we're gonna break this. We're gonna break from this while loop. And if our temp's item is equal to specified element, this time is found will be the equal to true, and we are increasing the counter. And we're gonna move ahead for the our next pointer, and not next pointer, next node. And if is found equals to false, I mean if we couldn't find a specified element, it shows this error message on here, like hasn't been found in the linked list. And if we found the specified element has it says element has been found successfully for I times. We are typing our counter on here, like I said before. Uh, if there are 3 number which is specified, it's gonna write 3 on here. And the last method on here, the print section, uh, it's printing all of the notes items in this section. I created a asterisk temp here again, and it starts from the head node, the very first node. And if our list length is not equal to 0, it's gonna start to print the all of the nodes items on here. And as you can see, the output section see out temp item, the temp nodes item value, and it's printing uh, on the same row. And again, we are moving to next node on here. We are declaring our temp next point memory address to temp again, and we are closing the parentheses on here, as you can see. And uh, if there is no node in the list or depleted, it says linked list doesn't exist, please insert the nodes first. And that's the only message when you have no nodes in your linked list. And that's the whole code. As you can see, I tried to explain as much as I can, but it's really hard because it's really long. And when you when you explain the code so long, you are starting to struggle with the explaining the whole code. And hello everyone. Sorry for the quick timestamp, because I really had to rest a bit, because it's really hard to explain all of the code. Uh, right now, we're gonna execute our program, and we're gonna see our user interface, and we're gonna make selections with switch cases, like if we type 1 from our keyboard and press the enter, we're gonna execute the add method from our class. If we press 2, we're gonna delete a specific element from our linked list. If we press 3, we're gonna search a specified element. If we're gonna print 4, we're gonna print all of the linked list and all of the nodes. I mean all of the items in the linked list. And if we press 5, we're gonna quickly close our program and let's execute our whole program. And as you can see, our user interface is appeared on the console. As you can see, it says welcome to linked list program. Select and enter your choice from the menu. And right now our linked list is empty. There are no nodes in it, and I want to print it. In that case, let's press 4 and press the enter, and it says linked list doesn't exist, please insert the node first. And let's add some nodes, like we have to press the 1 and we have to enter the number, and it says enter the element you want to append. Let's append number 5. uh, let's append again number 78. Let's append 10. Let's append 5 again. Let's append 5 again. Let's again and 9 maybe. Okay, and let's print our linked list. And right now, as you can see, our linked list shape is like this, and 5, 78, 10, 5, 5, and 9. And let's delete some specific elements from our linked list. Let's delete 9, okay? And I want to delete the 9. And it says 9 has been found, deleting, and we're gonna print our linked list again. And as you can see, element 9 is vanished from our linked list. There are no 9s in the linked list right now. And for the search section, let's search number 5 in our no, not the number 5. Firstly, let's search for the number 10, okay? Number 10, and it says element has been found successfully for 1 times. And what if we have a specific element, a specific number larger than amount of the 1? Let's for instance, we have 3 5s in the linked list, and let's search for the number 5. And this time it says element has been found successfully for 3 times, because we have 3 number 5s in the linked list. And what if we delete all of the nodes from the linked list? And let's delete 5s. Let's continue. Yeah, we've deleted the 5 again, and it says 5 doesn't exist in the linked list. I have to print it again. For seeing the remaining nodes, it's 78 and 10. Let's delete 10, and let's delete 78. And right now it says no nodes exist in the linked list, please append node. What if we try to delete a specific element from the linked list, and linked list is empty, has no nodes in it? Okay, let's press the 2 again for deleting, and I want to delete 98, let's say. And this time it says 98 doesn't exist in the linked list, and no nodes exist in the linked list, please append node. And what if we print the empty linked list? Let's press 4, and it says linked list doesn't exist, please insert the nodes first. Let's append some nodes again, like 10, 8, 57, like 61 and 100, and print it again. And as you can see, our linked list shape is right now like this. And I want to delete something more again, like again we're gonna delete 10, and it says 10 has been found deleting, and we're gonna print it again, and we have no more 10 numbers. Let's try to delete 10 again, and this time, like previously, uh, we try, like previously, 10 doesn't exist in the linked list, and yeah, we are done for that case, and let's close our program. Like typing the 5 from your keyboard and press the enter, and now it says closing the program, and right now our program won't be executed anymore. It's closed right now, and that's all. Thanks for watching.